So obviously, I'm not an expert on physiology as such, but this is a nice paper, and I'm going to just be very brief in introducing it. If you understand this topic, please read and follow up on the references. Typically, from climate science, we are always thinking about exceedances, wet bulb temperatures, and then epidemiologists come along and talk about exposures, vulnerability, risks, and so on. Physiology is something that we discussed a little bit in the previous mortality paper as well. This one is, providing a model for a physiological approach for assessing human survivability and livability to heat in a changing climate, and they offer some ways in which this approach, this model, can be combined with climate models. People also do econometric approaches where you just look at loss of labor availability, productivity, capacity, and so on in extreme heat events. So these are all useful. Obviously, I'm not an expert in all aspects of it, but we should be aware. I should be aware. So I think you can also use it if you want with this brief introduction. Most studies projecting human survivability limits to extreme heat with climate change use a 35 degrees C wet bulb temperature threshold without integrating variations in human physiology. So obviously, one size fits all doesn't work because it depends on age and other things, gender, etc. This study applies physiological and biophysical principles for young and older adults in sun or shade, to improve current estimates of survivability and introduce livability, so maximum safe sustained activity under current and future climates. I won't go into the future climate projections they provide, but essentially I wanted to introduce this idea of the model, and the model is given with equations, everything, which I'm going to skip as well. Our physiology-based survival limits show a vast underestimation of risks by the 35 degrees C wet bulb temperature model in hot, dry conditions. Updated survivability limits correspond to TW of 25.8 to 34.1 degrees C for the young people, and 21.9 to 33.7 degrees C for older people, 0.9 to 13.1 degrees C lower than the 35 degrees C threshold that's been used widely already. For older female adults, the estimates are 7.1 to 13.1 degrees C lower than 35 degrees C in dry conditions. Livability declines with sun exposure and humidity, of course, yet most dramatically with age. So 2.5 to 3.0 MEPS for lower for older adults. Okay, reductions in safe activity for younger and older adults between the present and future indicates a stronger impact from aging than warming. So it's an interesting statement. If you look at physiological consideration and look at the projections of warming, what is going to be a bigger impact? Is it the warming or the aging? They are basically saying that given the warming, aging is going to be a bigger impact on livability compared to the warming impact if you are kept somehow at the same age. Okay, so these are useful things. So obviously you don't want to hit any such limits, but you still should be aware so that you know just how close you are to those, because the effects on health, labor, etc. will begin to appear well below these limits in any case. Okay. Different definitions and approaches to survivability and livability, including terminologies in recent climate change and physiology literature. So we have here survivability, adaptability limit, livability, and critical wet bulb temperature, definitions and use. So there are references given here. I won't go into those, but individuals' core temperature exceeds 43 degrees C within a 3 to 6 hour exposure window, which determines survivability limits. Adaptability limit, an extreme upper limit of wet bulb temperature 35 degrees C to human heat adaptation due to climate warming, above which dissipation of heat becomes impossible when exposed to extended periods such as 6 hours, which results in death because the body is unable to get rid of the heat. Core temperature cannot cool down. Livability, maximum safe internal heat production and physical activity that a person can generate without a sustained rate of positive heat storage in the prevailing environment, thus allowing people to safely sustain work or play outside for an extended period. That is livability. You are not just sitting and trying to survive, you're actually able to function and work without reaching any dangerous thresholds. Critical wet bulb temperature, critical environmental limits, adaptability threshold for compensability. So the definition of livability in the current paper, valid for 1.8 METs, so light everyday activity. Let me take care of somebody knocking at my door. Sorry about that. Somebody trying to sell me mangoes in this hot weather. Poor old lady. But anyway, where was I? We were here. So we were, oops, my mouse has stopped working. So METs, I hope you know what that is. That is metabolic equivalents. Basically, for dancing, there is a certain amount of metabolic equivalent, running and so on. So those are the MET units. Okay, so you can see here for light everyday activity it is 1.8 MET, and we talked about another MET here somewhere. So it's heavier the activity, higher will be the MET. Okay, overview of environmental conditions, populations, assumptions and assessment types examined in the present study. Full model presented in supplementary information. All variables in the model remain constant during exposure. So wind, clothing, sweat rate, skin wettedness and so on. Core temperature and air temperature and relative humidity are used. So indoor and shaded, outdoors and sun exposed. Population types, of course, young healthy adult 18 to 40, older adults greater than 65 years. Young, same classification here. So radiation conditions from indoor or outdoor, population type, survivability limit, livability assessment and future livability. Tests for survivability, conditions that would elicit uncompensable heat stress leading to inevitable body heat storage and rising T-core to result in heat stroke in 3 to 6 hours. So all combinations of 25 to 60 degrees C air temperature or 0 to 100% relative humidity with constant winds are considered. Assumptions include things like nude, laying down and remain hydrated. So similarly, there are livability assessments of maximum metabolic heat production that can be physiologically compensated without a sustained continuous rate of heat storage, which means basically your body is unable to get rid of the heat and core temperature keeps going up. Future livability, change in M max, that's the metabolic equivalent max between contemporary, so 2016 to 2025, and future 2019 to 2100 estimates when T air is greater than 25 degrees C with constant 1 meter per second wind. These are idealized, but these are models that are being developed, and then they have to be combined with climate models and so on. There are many such figures. I'll show one. You are looking basically at estimates of survivability limits with the 35 degrees C wet bulb temperature shown in each case for indoor and shaded versus outdoor and sun exposed for young healthy adults at 18 to 40 and over 65 years with relative humidity on this axis. So it's always a combination of air temperature and relative humidity that we have to worry about when it comes to livability and survivability. So this is the new TW survivability limit for younger and older adults under shaded indoor or sun exposed outdoor conditions. Physiological heat stroke TW survivability limits with the thick black line here, modeled across 6 hours of constant exposure for young adults in A and C, and older adults in B and D in shaded indoor or sun exposed outdoor conditions. Zones 1 and 2 in yellow shaded regions here. So you are looking at the zones here. Represent areas of survivability, whereas zones 3 to 5 are non-survivable areas due to evaporative constraints. or restrictions from the environment, zone 3, sweating limits in zone 4. So you can see the colors here. Zone 4 is this one, zone 5 is this one, zone 3 is this orangish color up here. Okay, so exposure goes up here, and temperatures and humidity are varying here as well. You have to just map yourself, look at it, stare at it, and get a sense of how the limits vary. Obviously, when temperatures increase, survivable relative humidity drops, right? And temperatures are cooler, relative humidity can be higher, obvious, right? And so on. So I won't go into the details, but you get the idea. Physiological limit based on our physiological wet bulb survival temperature as modeled in the present study, and differences from 35 degrees C TW survivability assumption. So they look at exposure 3 hours, 6 hours, and look at relative humidity going from 20%, 25, 50, 75 to 100%. 100% relative humidity is not realistic anyways. Young adults, older adults, so TW limits, delta TW limits, so TW minus 35, and corresponding air temperature. Same things here. So obviously, as you increase exposure to 6 hours, everything drops. So it's 26.7 degrees C TW limit to survive. Here it will be 25.8 for younger adults, and for older adults it's 23.14, which is lower than younger adults, obviously, even for 3-hour exposure. For 6-hour exposure it will be 21.9, lower than older adults for 3-hour, and younger adults here for 6 hours as well. So that's similar. As you increase relative humidity, those temperatures, the TW limit to survive, go up. Okay, so you get the idea of what we mean by survivability limits and the livability limits. Okay, this is another figure, updated survival limits in extreme heat versus the TW of 35 degrees C assumption. And their idea is that this idea, the blanket number of 35 degrees C of wet bulb temperature that's been going around is basically something that has to be retired, because they compare TW equal to 35 degrees C assumption in the black line here with our physiological survivability limits. So you can see everything gets lower. So we are overestimating the survivability limit by assuming 35 degrees C for everybody, because this should depend on indoor, outdoor, sun shaded or not shaded, and also age group from young adults to older adults and so on. So the message is loud and clear, right? So you can see the differences in the ranges of survivability, livability for young and older adults. So they're nice table on future collaborative work among various subtopics and disciplines. I didn't put any part of the model in here, but if I have to just make a couple of points, what would I say here? There are some equations. Let me just read it on the fly. Discussion. They have a nice long section on in the method section. They provide the modeling details for livability estimates and for survivability estimates and so on and so forth. Should I read that? Well, maybe not. I'll just leave it. You can follow up if you're really curious about it. Okay, so let's just look at future collaborative work among various subtopics and disciplines. Thermal physiology, future work, next steps based on model capabilities. Create a catalog of specific estimates of skin wetness, skin temperature, and maximum sweat rates across population types, ages, medications, intake, and health disorders, chronic diseases, etc. And just to jump ahead, conduct experiments across a range of plausible biophysical parameters for uncertainty estimations and subsequent model application across different temperature, humidity combinations along the survivability and livability threshold curves that we looked at here. So will we get to this stage at some point? Well, if we want to think ahead 20 years, maybe we will be doing this kind of heat wave management at individual levels, not just group levels or region levels. And in that case, such details of modeling and testing clothing factors, age groups, and I'm really having a hiccup. Improving, estimates of risk based on plausible biophysical parameters and so on may come into picture, but it's exciting to think that we will get to that level of managing heat waves. Or maybe we'll just have technology where your clothes are doing cooling and heating as required, and you don't need any building. You just wear a hat with some chip that cools your head. Shirt, pant, everything is just cooling you to keep your temperatures and sweating rates and physiological parameters within not only survivability limit but livability limit, because remember, livability means you are also allowed to have some activities for extended periods and not just sitting and trying to survive, right? So climate sciences, what do they have to do? Run the present model using multiple GCMs and emission scenarios to provide an ensemble of futures addressing various sources of uncertainty, including that from both biophysical and climate models. So it's combining the two models. Obtain regional or city-specific analysis of future heat stress with downscale bias-corrected climate projections. Quantify the probability of exceptional heat wave and or mass fatality events over different regions with different levels of climate change. These are great ideas. We definitely need to get to realistic timescales of predictions, like out to 10 years, 20 years. Not necessarily have to worry about 2100, but provide information at a very local scale. Public health people, determine the sources of differences between physiological models and epidemiological models to inform future model improvements. Quantify compounding and cascading risks connected to heat and health, including heat waves compounded by wildfires, pollution. There could be droughts involved and so on. Evaluate the extent to which different urban designs would alter livability or survivability. So it's a wish list, but a nice one. Leverage the new modeling capabilities along with projected global demographics to better determine impacts across a diverse population for public health preparedness. Okay, so jumping ahead, just reading briefly the summary. In summary, this paper establishes an advanced modeling approach based on human physiology for assessing survivability and livability across subpopulations, so younger and older female adults, and diverse climates suitable for application with global climate model output. Among survivability assessments, we fill specific gaps around these factors across the full spectrum of temperature and humidity combinations as compared to the common TW of 35 degrees C threshold, and introduce a new method to determine livability. Results show a vast overestimation of human limits to survival when using the 35 degree CTW survivability assumption, especially for older adults and hot, dry regions. Compared to the 35 degree CTW, differences in physiological survival limits range from 0.9 degree CTW lower, younger adults humid conditions, to 13.1 degree CTW lower for older adults in dry conditions compared to 35 degrees C. By the end of century, livability declines are expected mainly in already populated and heat vulnerable regions. Reductions in safe sustained activity levels between present time and end of century in young and old adults indicate a stronger impact from aging on heat health risk than from warming. Thus, the spatial extent and intensity of intolerable heat stress in an aging population cannot be underestimated. There's such a related point there, with fertility rates dropping everywhere, many countries already hitting peak populations. We may have much lower density of population by 2100 or even earlier. that could reduce exposure in many ways as well. And if technology keeps going, as I said, maybe we'll be just walking around with shoes that cool, hats that cool, clothes that cool, and so on and so forth. This work addresses fundamental shortcomings of common models estimating future human habitability or survivability by taking a physiological approach while opening avenues for more robust analysis, as we saw in this table, a wish list. Results and the flexible approach will advance methods in global survivability and livability analysis under increasing heat stress. Findings underline the need for continued research efforts and investments in heat risk management, adaptive capacity, and technological innovation for personal heat protection in vulnerable global regions. Early warnings are very critical. Hopefully, we will have hyper-local early warnings very soon as well. There is a nice program called Early Warnings for All, which is advocating for this. I have lots of podcasts on early warnings that you can look up if you wish. Okay, so sorry that's very brief, but you can follow up with the paper. It's a very nice paper. I wish I understood all the details, but I hope I translated the most important points to you in a meaningful way. Leave a comment if you feel it didn't help you. Thank you.